Rigorous. Why is rigorous a pro?
We know it's true.
We don't doubt it.
Given like.
Yeah, we kind of, yeah, okay, we know it's true. Someone want to push back on that? How do you, I want to hear like your real feelings. Like now, if you could just like hate this, you can say so. I want to hear from you also. I kind of hate it. I mean, who would like this? It's hard.
Wait,
It's terrible.
like, if you.
Why do I hate it? Because it's like so annoying. It's like so long and complicated
But
and
like
hard.
someone's already done it, so like you
You're
can
up.
just like.
It feels annoying, but it's also like satisfying because there's like no doubt in like any of it. So it's like it's annoying to actually do it, but when you understand it, it feels like.
Euro is feeling the rigor. Euro feels the rigor. Euro says, I like this because, yo, I don't need to like worry that someone's like trying to trick me or whatever, right? I can just go through line by line by line, carefully checking every single step and making sure that it follows from the previous steps. What's on this board? No pictures. No intuition whatsoever. You don't need to understand what the hell is going on actually, and you may not at any point in this entire board. All you have to be able to do is just follow the individual little steps one after another and make sure that they follow from the previous one.
The individual steps are based on intuition.
Oh, an objection.
Like, wait, seriously, our logical basis is like formed on the back of intuition.
Yeah, Connor says there's not enough rigor. After all, so wait, this is a good conversation. What must one already accept and understand in order to be able to execute this proof? Let's list all the things.
Yeah.
You have to know the definition of least upper bound, okay? I was thinking more, yeah, you need to just, this is more to Connor's word. Connor says, dude, I am constantly at every single step, like using like logic, right?
Yeah.
Yeah, that's like worth mentioning, right? That none of this goes through without just like, without some like strict logic. And if we were doing this like super hardcore, we would have it like in a big Fitch style proof. Weierstrass didn't do it in a Fitch style proof. Weierstrass kind of just did it like this, you know, like in German words, and kind of skipped a lot of steps and just assumed that you could fill them in if you needed to. Okay, what else must we accept besides just logic itself? Yeah.
But there's, even though we're like saying that we've listed every step, there are like a gajillion steps that are like going on behind the scenes.
Such as?
Such as like, just like properties of inequalities.
Yeah,
conditions.
okay, good. I'm glad you mentioned that. Properties of inequalities, right? You need to be like a pretty much level 10 expert on inequalities to do like epsilon delta proofs. Like that happens all the time. And like there's tons and tons of properties of inequalities that I'm using with the real numbers all the time. Like, you know, all these various like absolute values and all the trichotomy and all these other things. Yeah, so we need to have proven those, which we kind of like did, right, with the Dedekind cuts. Yeah?
Like you have to like accept our axiomatization of the real numbers, like with any of this.
Yeah, that's another thing. David Wu says, dude, what is lying at the entire heart of this proof? What's doing all the hard work? Well, okay, numbers. Yeah, numbers are doing a lot of the work, but also the least upper bound axiom. And I would like to stress just how much this arithmetization of analysis kind of like subverts the traditional way in which we think of the axiomatic method. Because the traditional way that we think about the axiomatic method, the Euclidean way, right? You take a couple of postulates which are ridiculously obviously true. And from that, you prove things that are far less obvious, like that an orthocenter exists or whatever, right? But here, which are you more confident of? The intermediate value theorem or the least upper bound axiom? Yeah, like the intermediate value theorem is like more intuitively true, one might argue, than the least upper bound axiom. And so what's going on by the time we get to the 19th century, the good thing is we're delving deeper and deeper and deeper into what's really going on. And it turns out that if you accept the least upper bound axiom, then all of these things can be proven. But the least upper bound axiom is like far from obviously true. And in fact, what we are now sort of being forced to do is to like accept as axioms things which are extremely abstract and like not obvious at all. And then from those like prove obvious things. Do you find that kind of weird? It's kind of weird. Yeah.
Can we do the converse?
Can you do the converse? Someone have asked me before, I'm not sure. And you might ask, suppose we could, because people have said, hey, why don't we just make the intermediate value theorem an axiom and like prove the least upper bound axiom from that, something like that, right?
That's possible. It's an equivalent
It is?
definition
It is?
of completeness.
Oh, it is possible. Oh, George says yes.
It's probably less
Okay,
useful, though.
yeah, George says yes. Yeah, and so you might ask, dude, why is the least upper bound axiom our axiom then versus the intermediate value theorem? Well, then this sort of uses the other kind of notion of an axiom, which is like, you know, it seems like you keep trying to do these proofs, right? You keep trying to prove that bounded monotonic sequences have a limit. You keep trying to prove the intermediate value theorem. You try to prove the extreme value theorem. You try to prove Bolzano-Weierstrass. And every single time you get to a point where you're like, damn, it would be really nice if I had the least upper bound axiom, right? It turns out that this is the thing that's like doing all the work, right? And so that kind of becomes the axiom because it's the thing that can be used to prove all the other things. But I think we've left the zone of like, you know, the way it's supposed to go is that the confidence in the truth of the statement flows from the obvious confidence in the truth of the axioms down to the less obvious things. And I think by the time you get to the end of the 19th century, it's going in the opposite way. We have these axioms that are so abstract that I don't even know how to possibly even know if they're true or not anymore.
They can almost be justified by their consequences.
Yeah, they can almost be justified. Yeah, you can almost just be like, I guess this axiom's true because when I use it, I prove a bunch of things that are true. It's like sort of weird, right? Yeah. Other comments? Yo.
Yeah, it's like we're becoming physicists. We're sacrificing like intuitive knowledge for like actual usefulness.
Kind of, yeah. But in some ways that's always true. With any axiomization, that's kind of true, right?
Yeah,
that
but
we're sort of
in this case, what we're doing is we're choosing our axioms based on their usefulness in proofs rather than like their actual understandability.
All right, cool. So yeah, this is if you take an analysis class in college, unfortunately, you'll get a lot of this. And you'll either love it or you'll hate it. Hopefully you'll get a really good professor who, you know, will explain things well, because the textbooks often they go all rigor and very little understanding. So anyway, this is math now. Hope you like it, you people who got rid of geometry. This is what we're left with. Tedious, long lines of inequalities. It's kind of terrible, right? Yeah. That's why I have left the world of analysis. I only care about
A lot
polyhedra.
of steps. Oh, like construct. If you're doing this fully rigorously, like construct 2 using a Dedekind cut, then prove that 2 has
Yeah.
the inverse, then prove that delta times the inverse of 2, blah blah blah. Prove
Yeah.
that C plus delta over
Yeah.
2 is in the real numbers.
Yeah, we're sort of doing this out of order, and we should have done this probably last week. And then you at the end of this class, like right now, you might be asking, well, why is the least upper bound axiom true? Well, then you would go and do the Dedekind cuts, right? And you could show that every set of real numbers has a least upper bound by constructing the least upper bound. Okay. So all right, I think that's a good place to stop. The only thing I want to say is that whoever said there's not enough rigor here, you're not alone. Frege looked at this and said, not enough rigor. And so that's why he invented Fichte-style proofs, basically, in order to make this even more rigorous.
I was actually advising you to just like focus on being very rigorous because
Frege says the logical principles themselves must be axiomatized. All right, goodbye, Internet.
yeah,
Everyone say
no matter
goodbye?
how rigorous